a great pleasure to have Mr. Karthikeyan back on campus. He was one of the most wonderful student of DGCT. Uh, I happen to understand how what a wonderful engineer Karthikeyan is when he showed me his project in the second year. He was a lateral entry student, and like you, he was very new to college, but and he came and displayed that, and he said, "Ma'am, he worked before joining the college. After completing his diploma, that's very important to note that he worked in the industry for a year and then came to do his engineering, and that's why he could understand what he has to learn. See, what's happening today is you join a course and you simply start following the curriculum, the labs, the assignments, the projects. But somewhere down the line, you forget what you really need to learn for the industry. And that's what exactly Karthikeyan had figured out in second year itself. What he needs to learn to become a good engineer and what he needs to learn to become suitable for the industry. And that's how his journey began. And then he did a lot of patents, wrote papers, did a lot of projects, participated in so many events when he was in the college, took every opportunity to show to get challenged with different problems, technical problems, and solve them. And we can never forget his valuable contribution to the design center, to the IIPC, and his interaction with Chairman Sir, our founder Chairman Sir. I still remember founder Chairman Sir would especially call him to the cabin whenever he comes to college. And where is that young boy? I'm so impressed with this work, and we have to help him to do the best. Then, after completing his degree, he goes to IIT and then works with one of the best in automotive industry. And in fact, they even sponsored him to do a master's and PhD in Germany, right, Karthikeyan? And I think he just got busy with his work and did not pursue it. But to get this opportunity from industry is something very, very appreciable. And I'm so happy to know till today, he has 7 patents on his name. Seven or more.
As of now,
Please
7.
unmute
As of
yourself.
now, 7.
Yeah, 7. Yeah. So, students, you're in the first year, but as you come to the third year and final year, you will come to realize how difficult it is to get a patent. Maybe now you not don't even know what a patent means, but once you meet the core team, the department, you will realize what is a patent, what is its importance, and how difficult, um, how very challenging it is to register a patent and get it on your name. We have our faculty members doing it. Principal sir has 2 patents on his name, and many faculty members have started getting a patent. So we want you to start seeing this, getting inspired by this talk today. And I'm sure Karthikeyan will do it in a very, very simple, straightforward manner. That is what he is known for. No fancy talking. He will be very, very straight explanation of what his journey has been. And it is definitely going to inspire you all. I'm really happy that so many students have joined. And we are waiting to hear from you, Karthikeyan. And please leave them inspired, and they can contact you. You can leave your numbers so that the students feel free to contact you if they want to do something like you. Thank you so much. Thank you, Pardaman sir, for finding out such a wonderful speaker today for the
Thank you,
talk,
ma'am,
and I wish
for
you all
your
the best. Thank you.
wonderful speech. And now I invite our today's speaker, Mr. S. Karthikeyan. Hand over the session, sir.
Yeah. I am presenting the screen. Kindly let me know once it is visible. So, is my screen visible now?
Sir, Yeah, now visible, sir.
So
Please.
it is part of my introduction. Can all of you please mute yourself? I'm getting some noise. Thank you. So, as explained earlier during the introduction session, so basically, I work in Denmark in R&D, and I take care of the vehicle architecture. And now, recently, I'm taking care of the innovations in the complete R&D department. So I'll be responsible for the Trust Asia, so Japan, India, and the other countries which we have plans. And also, I'm doing my master's in IT Madras on the mechanical design discipline. And apart from this, I'm also an independent scientist. So my research fields are on mechanical engines, self-balancing robots, self-balancing vehicles, and I'm also fond of developing robots. So I work on intelligent robots. So these robots mainly, it has the human sensors inbuilt into it. So still, I'm working on this on improvising. Yeah. So and also mainly as a product, you see, as a product, I work on autonomous vehicles. So autonomous vehicles means it,
Sorry for the
yeah.
disturbance, Karthikeyan, sir. Hello, sir. Your voice is somewhat
Okay. Okay.
break.
I will
Please
turn
check.
off my video. I have turned off my video. Hope my bandwidth will be okay.
Ah, now your voice is okay, sir.
Okay.
Please.
Okay, I will continue session without video so that the bandwidth will be okay. So to continue, yeah, my research on product is mainly on autonomous vehicles. So autonomous vehicles, you might be knowing it. It is a complete manless vehicle. So I developed a manless truck. You know, it can be controlled through a remote, basically IoT built in, and it can be controlled through Wi-Fi. The operations which a manual driver will do, this vehicle will also do. But the conventional autonomous truck and my truck has some difference. It is mainly on the manual transmission. So the existing autonomous trucks are on AMT or AT transmission. So this will be on my MT transmission. So this is one highlight on that, and I have more patents on this research. I also work on a cooling system. You know, I have developed a cooling system with magnetocalorific effect. So this is not something which we have like CFC or HFC based cooling. This is a material based cooling. So whenever you magnetize or demagnetize materials, it will generate temperature, right? Because of the molecular movements inside the material. So there are some special materials which can be utilized for cooling system. So I worked on the research and developed a cooling system based on this magnetic calorific effect. Basically, it is derived from the invention of Marie Curie. So I have just made it as a product, but the main invention was from Marie Curie's invention. So yeah. Yeah, now I request all of you, you can go to this menti.com and use this code and answer these questions. We'll begin with this. So, start. Yeah, you can go to menti.com and use 8547 4360 code and answer these questions. So able to do it or any problem? So able to good. So feeling energetic, fine, good. I see more participants, like more than 130, but I got only three responses. Yeah, you're bored. Someone is feeling very bored. Fine. Okay, we can move to next question. What is your expectation from this session? So you can start answering for the second question. What is your expectation from this session? Yeah, logic. It is a motivational session. Thank you. Anything else? We'll learn new things and get motivated. True. Yeah. So okay, fine. Then we will move on. Less response. Fine. Okay. Yeah, as you told, it is a motivational session. As someone told, it will not be boring today. I will do my best that you will not get bored. And the expectations, I hope I will fulfill it. Okay, I will try to motivate you all. Thank you for that. So we'll start with the video. So we'll start with the video. Okay. So I hope you all saw the video. You see, the invention starts with curiosity, okay? And it starts when you start ignoring. The video shows the same. So if you are more ignorant towards accepting new things and you don't develop curiosity, then that's the end point of innovation. So always be curious, okay, to learn new things and always stay with the basics. With this message, yeah, always innovation starts with problem. Okay, I in my um, learnings or in my view on innovation, what I learned about for almost 10 years in my technical career, um, always start with the problem with respect to any product. So we all know we had this very hard with a larger than telephone, and we had some limitations to it. It is not portable, it is wired, and you have to um, scroll the complete dial pad to the end to dial each digit of the number. And we evolved and we developed a few things like we developed a pager in 90s. Even I experienced, I used pages when I was a school kid. And we had this mobile phone with an antenna connected, but with a very small display. And later we had mobile phone with some features added to it. And we later moved to a mobile phone with stylus, but with a dial pad. We had tape recorders, we had Walkmans, and then we had music sticks. Like this is a Sony stick. Most of these products you might not have seen or used, but this is how your current products are being evolved. There were those days when you want to use internet, you have to go to a internet center and we have to use this internet. Even we had Yahoo that time before Gmail. Yahoo was very famous, and we had this device. I think you might not have seen these devices. These are all FM radios of older days. And we had gaming consoles, we had alarm clocks. All these are now available in one device, in a smartphone. So when Apple invented a smartphone with a single button, uh, all the features, whatever you're seeing here, are already inbuilt into it. You can access your emails, FM, alarm, games, music, video, everything is in one device. This is how innovation evolves. So this clearly shows or delivers a message that every innovation starts with a problem. You have to first understand the problem. Like whenever you see a product, you see how to um, improvise the product or how to make it more futuristic. Like today we have mobile phones with what to say, a feature of something, but tomorrow you might have a mobile phone with a lot of feature replacing a laptop also. We don't know. So you have to be more futuristic in solving a problem. That's the point where innovation starts. Okay. So this is the message of the learnings in my innovation career. So think out of the box. Don't stay in a closed room. Okay, don't be ignorant to thoughts with your own judgments. So you don't always judge things on your own. You leave it to others and get opinions, and you don't do uh, solutions with a predefined manner. So you don't develop a solution and then find a problem to the propose the solution. You just have more than one solution. The feasible solution we can always have it brainstormed and finalized, but you don't go with predefined solution. And forget about your past results and failures for a moment, especially during the innovation thinking, or you're in the phase of idea evaluation. Don't always stick to the past results and failures, because in the past we might have used less accurate tools or devices, or it may be due to various environmental factors. We don't know. So you don't limit your ideas or thought process based on your past results and failures. Always mix and match concepts. If you remember the previous example of a mobile phone, the current smartphone is nothing but a mix and match of various devices, right? You had a gaming console, alarm clock, internet, all are mix and match concepts. So that's where the synchronization or the idea evaluation will yield to a very good saturation point. So always mix and match your concepts. And as I always say, always stick to the basics. Basics only gives you more strength and confidence in idea evaluation or idea generation process. So there is nothing wrong in talking about basics. You ask questions, you ask various questions related to things which you feel it has to be sorted out. And you do brainstorm. See, people do brainstorming in such a manner, like they are trying to judge and go with a predefined solution, or they don't allow others to open their points. You don't do that. During brainstorming of any innovation thought process, you have to write down or note down points more peacefully. You just go to a quiet room, discuss with your close people who can also who are also in the same wavelength of innovation thought. You can discuss with them. They may be on a different streams. They may be on a computer science, IT, or mechanical, civil. There is no limitation to it, but you just don't argue or don't limit your thought process during the brainstorming session. You note down all the possible ways that you can address an problem. And this is where the innovation kickstarts or begins with. During discussions at any, it's not only for the inventions or during idea generation, always any point in your life, don't argue. Try to discuss and get others' opinion. This leads to a very good maturity in your discussion. You will have a good outcome when you try to discuss. When you try to argue, you always stick to your own idea or thought process. You will not know others' opinion. So always listen to your seniors, listen to your faculty members, teachers, parents. You discuss with them, don't argue. So this is where you start your innovation. Okay, these are some of the key points I wanted to discuss with you when you are thinking out of the box. So when you do all these things like this fish, you will also go out of the box and do wonders in innovation. Okay. Now, okay, I think there will be some mechanical students will be there to at least get these ideas. But nevertheless, this will be very easy with this automotive example for all the people here. Now we will see an example, okay, how we think innovatively with this car. So my first question: how this car will move? First, I'm not an engineer, and I wanted to know how this car will move. So I'm asking this question to an engineer. So what he will answer. So he will first see the problem mathematically. So this is how you have to see or look into a problem and look for an innovative solution. So look at the system or problem with a more systematic way mathematically, and always stick to your basics. So this is the message. And so how this car will move, we have to have tractive force in the wheel ends so that the car will start moving. And we know how to calculate the tractive force for this vehicle. It is quite simple. You don't need to be a rocket scientist to know this, but you have to be having some engineering background. That's all. So it's nothing but you have engine, you have drive line, you have the axle, you have the connected gears, and you have the tires. So you have all the components in front of you. With this, you can calculate. So it is nothing but 2 pi into engine torque, into efficiency, into rear axle ratio, into transmission ratio, into transfer case ratio in case of an all-wheel drive, and you just divide the whole part with the rolling radius of the tire. So, so this particular example is quite similar to Swift car. I took some values from internet, to calculate for this session alone. So you can see we are calculating it for the fifth gear. So assume that you are driving in fifth gear in a Swift car. So what will be the tractive force you will be getting in this car? So you'll be getting around 3.5 kilonewton, and the power required, to move, or the power at this particular connected condition would be around 48 kilowatts or 65 HP. So this is how we calculate. So what is more innovative into it? Nothing, right? But you have to think. Now we have a problem statement. So we need to find an alternative power plant for this above car. So this all the above example what we saw on the source power, this is on a engine based concept, right? So now if you want to develop an alternative power plant, you know, we have to replace these components. So how we can innovatively think. So we have hybrid vehicles. I think most of us are driving cars these days and aware of these concepts. So we have hybrid vehicles. It is nothing but an engine plus electric motor. We have full electric um, vehicles, and we also have some more innovative concepts like hydrogen powered fuel cell vehicles, and you can also think of even nuclear power plant. No one is going to stop it. You have to know the limitations. So during invention, so when people who invented engine, if they tried restricting to engine itself, the alternative power plant options, what we have today, might not have come across. So how we can solve these problems? We just replace these components, engine torque and efficiency, with the values from electric motor or a hybrid engine plus torque power platform. You can fit in here, or you can fit in the values for fuel cell, and you can easily find out the best fit for the replacement of the above engine based vehicle. So this is one of the examples I wanted to give an insight, like how you, when you are solving any problem technically, you have to first look at the problem more systematically and mathematically. You try to develop mathematical models in MATLAB or Octave, you know. And after solving this mathematical model, you'll come across some set of solutions, and you just fitting those solutions to the existing options, like you have hybrid, full electric, or fuel cell. This is some of the examples. Or if you don't find any proper fit for this particular problem, you always try to do the things which we just saw earlier. You just have to think out of the box. You start with problem, you try to fit the existing solution. If you don't find existing solutions convincing, you always brainstorm and arrive upon more solutions. Uh, I think someone has muted. Can all of you please mute yourself? Okay, thank you. This is the approach I used to follow. This is more practical way that you address any. I think again someone has muted. Please mute yourself. Thank you. So, yeah, with this, I want to give some insights on the learnings I have as an inventor. So, you always have to give more time for reading things. Reading is the base, or it is the place where your wisdom gets widened and your knowledge gets widened. So you do more the field, you have to do more field work. You do read patterns, journals, and research papers. This gives you a lot of inspiration, like I had in my past. Today also I used to read lot of uh, previous patterns and the research papers in the available time. So you also try to create a practice of reading more research oriented papers in your free time and make it as a habit and dedicate time whenever you have for the inventions. So we used to spend more than 3 to 4 hours on TV, mobile phones. We do a lot of non-value adding activities. So we don't know, like it depends on person to person, like the perception on its value adding or non-value adding. We don't know. But if you are an inventor, you want to have some thought process about the inventor, dedicate more time, give more time to the field of your research work. And since most of your day scholars, you go home and get tired and do relaxing. If you're in hostel, you will have more time, and you give more time to reading and dedicate your time in your library. That will increase your technical skills. Okay, and so we always proceed more systematically with mathematical approach. So we have several set of concepts like this. So you utilize those concepts in your mathematical approach in problem solving, and audio is not clear. Audio is not working. Is my audio is okay now? I just got message. Okay, I take it as fine. Okay. So to continue, so learn new things. Being a mechanical engineer, I had no clue on coding. But when I started working on problems, like when I started working on robotics and self-balancing robots and vehicles, then I came to know the importance of coding. So coding is not only for the software people. So don't go with a lot of assumptions. You just have to be more practical these days. Try to learn codings. Even you have free sessions in MATLAB official website. You can log in. You can do certified free courses in MATLAB official websites itself. It is totally free. So you just have to dedicate your time in finding those things and do um, learnings. So don't go with the assumption that It is not only for the software people, but also for the people who work on mechatronic systems. So all the trust me, when you're into industries, almost 100%, I would say 100% of the components are mechatronics based components only. And the vehicles today, what you see or drive, whether it may be a two-wheeler or four-wheeler or a truck or even a trailer which goes in the highways, all these vehicles today are moving towards more mechatronics based concepts. The features that you don't even dream of, the government is trying to bring in. You might not be aware by 2023, we will be having a frontal collision warning system in trucks, which means for cars, it will be even before that. So when a system is coming to trucks, which means the government is taking more actions or steps towards safety of the passengers or the uh, drivers on road. So whenever the government is also trying to take actions in such an innovative manner, the products also have to be more innovative way, and it has to meet the expectations of the regulation. So since you are all going to be a future engineers working in R&D, procurement or supply chain, we don't know. But your contribution towards this is going to be very crucial. You are going to be more responsible as a citizen when you are developing product. So the message here is you try to learn coding now itself. Start with today. You have time and always use smart tools. I am not aware of MATLAB to be frank. MATLAB, Python before I entered engineering. So after my engineering, I started using MATLAB. I use Arduino development boards in my um, projects whenever I have to use the microcontrollers. So I learned some codings from Python and C. So there are some open resources you have like Arduino. It is quite free. The board is costlier, but you have to the coding part you can easily do by just learning through YouTube. So systems and things are very easy these days to learn. So you just have to invest your time in learning. So when I started using MATLAB, I saved a lot of time in solving my mathematical problems. When you go into your second year, third year, you have to use some mathematical um, concepts like Gauss elimination or Gauss zone. I also used those principles or tools in my problems. You know, in engineering, I just stopped with almost 3 to 4 iterations, not more than that. But when I used this software, I went till 50,000 or 1 lakh iterations. But this software will do in 15, 20 minutes, not more than that. So your solutions will be arrived more faster and you will have a lot of um, ways to improvise your solution. You can vary your parameters, your limits, or your boundary conditions, what else. So environmental factors, all these things you can very simply. You just have to build a basic code. You have to vary the environmental factors and get results. So this is how I get benefit out of MATLAB. And simulation part, if you are a mechanical engineer, try to learn more softwares like Abacus is there, Nastran is there. You guys might not know Nastran is what being used in NASA also, and that software is also used in automotive industries. Like I used to work in Nastran these days. You can learn these softwares online, but if you want to get some certification, you try to go to some institutions or if our college is also offering this course, you just enroll it. You just do learning and get certified. So whenever you get more knowledge or use more tools, your wisdom actually increases. You know, your thought process will also increase. You start um, getting experienced. You just don't be a learner or don't be in the starting level. You just improvise and go to the next ladder. Okay. Now the uh, most important point here, whenever your concept or innovation phase, don't feel down. Okay, it is just an iteration. Just keep it in such a way, just an iteration. You have to do more than one iterations to um, find the best fit for your problem statement. So whenever you have failure during your concept evaluation, you just take it as an experience and move on. It is just an iteration in your research work. Just keep it in a such a way. Okay. Okay. Now we are moving towards closure of the session. I will play a video. Someone said the audio is not working. Let me see if I can sort out before sharing this video. Okay. Um, can some of you please confirm once the video starts if the audio is working? Okay, then I have to skip this video for now. Uh, but the message from this video is to try to see if you can grasp something. Okay, so from the video we just saw, you know, the management is expecting a change, but everyone is in a different way. So you always start with change. You just don't be the someone who's already there with a rigid mindset, who's not willing to change. You just start with the change and start the change from today. Always stay hungry on problem solving and stay curious towards learning new things. So the final message here, you might not have you might have seen this already many times, but you might not have known this. There is a tier notch. It's a great invention and it is a patented innovation. This simple tier notch in a pouch or a packet, you know, it's one of the most innovative concepts which we come across daily. And most of us don't even realize this is uh, the ease that a tier notch offers, and it is a simple notch that brings ease. And we can say it's a cool invention. So the message here is whenever your invention brings ease to the people, they don't even realize there is something there. So that's why it is a great invention, and we don't even know that is a patented invention. So invent something simple but having more impact to the society. Okay, and with this message, we go again to Menti, and I expect you all enter this particular code which you see now. Yeah, now you can able to go to this menti.com and enter this particular code 27245045, and you can answer the multiple choice question which pops over the screen. Can already start voting. No one has started yet. Can someone respond? Yeah, I see one vote. Could see more than 100 participants. So let's take a minute for people to access and give voting. I wanted a bell curve, but yeah. Okay. So okay, so we can close the voting now. Let's see. Thank you for that. Around 8 people voted so far, and I arrived some sort of bell curve. I'm not sure. Okay, 25% said. Thank you that it was created some impact to you. So thank you for that. So any questions? I'm open to questions now. You can ask questions. I can able to answer those if you have any. If you don't have access for audio, you're watching TV, no problem. You can just type here. I can able to answer it. So if you have any questions, you can ask. Maybe not only about the presentation. If you want any guidance or any support from my side, I can able to give you. You can ask questions. A few people started leaving already. Okay, I take it as no questions from the participants. So then thank you all for your valuable time. And I think I have created some impact um, in your thought process. So as said earlier, I will post my mobile number. Okay, so this is the only number I have, so you can note it down. For any support on professional front or educational front, you can always reach me out. If you want guidance, also you can reach me out. So don't hesitate. If no other points, I think we can close this session. Thank you, participants, for your valuable time.
Thank you, Mr. Karthikeyan, sir. On behalf of the Rajiv Gandhi College of Technology, IIC, sir, I would like to thank our management, our secretary, madam, principal, sir, and vice principal, sir, for giving the permission to conduct this program on my story motivation session by successful innovator through virtual mode to our young engineers. Thank you, sir and madam. Now, I would like to thank our today's speaker, Mr. S. Karthikeyan, sir, for his wonderful presentation about the various innovative ideas and practical examples sharing to us. I hope our students learn more innovative ideas from your presentation, sir. Thank you so much, sir, for spending more time with us. Finally, I would like to thank our faculties and the students for successfully participating in this webinar. Thank you all. Now, I will share the feedback form link in the chat box. Please fill the form and submit it. E-certificate provided to all the participants. Good luck. Thank you all.
Thank you.
Thank you, Gautam, sir. Thank you for.